Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4. And then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 3/20. So the answer is 5 3/20. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now we've got this proportionality sign here, and to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here. Y equals 7.9x. And that is actually our answer. So the symbol here basically means and. And the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. Factorising is the opposite of expanding. So instead of removing things from a bracket, we're actually putting them in a bracket. And so we're going to start off by just putting the bracket down. And we're going to think, well, what can we put on the outside? So we look at the 20x squared and the 35x. And we first of all think of the number. So we're looking for the biggest number that goes into 20 and 35. Essentially, its highest common factor. Well, that's going to be 5. And then we look at the letters. So we look at the most amount of letters we can divide out. Well, this only has an x here, so it's just going to be an x. Then what we're going to need to ask ourselves is 5x times what is 20x squared? Well, 5 times 4 is 20, and x times x is x squared. Then to get the second term in the bracket, we ask ourselves, what times 5 is 35? Well, that's going to be 7. And what times x is x? Well, we don't need an x on the end of that. 5x times 7 is 35x. And you can actually expand that, and you can use any method you want, but I'll use Smiles and Rainbows. And so we're going to do 5x times 4x, which is 20x squared, and 5x times 7, which is 35x. So our answer will be 5x brackets 4x plus 7. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in 2s, so this will be 28, so the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So the distance initially travelled is going to be 14 kilometres for this stint here. And then we have a bit of a rest. A horizontal and distance time graph is essentially stopped. But then here we start up again to go home. And so that's another 14 kilometres travelled. So in total, there has been 28 kilometres travelled. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything, or we could just write y equals 9x. I'm going to say plus 5. A frequency polygon is like a line graph. In fact, it's a type of line graph. But it is when you have the data in a group. So we've got the data here as a group of 0 to 80. So there are 11 at 0 to 80, and then 18 at 80 to 160, and 6 at 160 to 240. Now, where am I going to plot this? It will involve putting a cross somewhere on this graph, and it would seem unfair if I put it all at 0, and it would also seem unfair if I put it all at 80. So what we do is we find the midpoint, the halfway point between 0 and 80, which is obviously 40, and we plot our coordinate there. So it seems to be going up in 2s, so it would be there. So that's at 40, 11, the coordinate. Our next one, we plot at the midpoint again, which would be 120, and it's just halfway between 80 and 160, and it's 18 high, so it would be up here. And then the final one is at 200, and it will be 6 high, so 200 is halfway, and we're looking at 6 high, so it will be here. Then when you're done, you need to join them up with straight lines. So I'm just going to get my ruler, join them up, perfectly straight lines, and there we are. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78, and we must write down the reason, so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. When working out if two triangles are congruent, which means they're the same, you can either have RHS, which is a right angle hypotenuse side. You can have three sides that are the same. You can have two angles then a side, or an angle then a side then an angle, or you can have a side then an angle then a side. In this question, we have a right angle. We only have two sides, so we can cross this one out. And if you look, that the two sides are next to each other, then the angle. So it's ASS or SSA. So these don't really fit. But the angle is a right angle. So we've got a right angle on both of them. We have the hypotenuse. And we have a different side that are all equal. So the proof here is RHS. So we're told the length of this rectangle is u, and the width is u plus 2. Doesn't matter which way around we do it. And we're told the area is 80. So we can actually write an equation from this. So u times u plus 2. So that's the length times the width is equal to the area, which is 80. So let's expand this. And what we're going to do is we're going to put everything to the same side. So all I'm going to do here is subtract 80 from both sides. And so we've got u squared plus 2u minus 80 equals 0. Now we're going to be using quadratics, so we're going to factorise this. And so we need two numbers that add together to make 2 and times together to make minus 80. So I'm going to put my brackets out. So we're going to have u at the start of the brackets, and let's have a think. So it's going to be 8 and 10, and one of them will be positive, one of them will be negative. Well, to add them together to make 2, the 10 will have to be positive, and then the 8 would have to be negative. And then minus 8 times 10 is minus 80. Okay, last thing is we get each of our equations equal to, each of our brackets equal to 0. So we can solve them. let's just do this in normal colour. So u minus 8 equals 0, and let's solve that. And so we're going to add 8 both sides, and we've got u equals 8. And we're going to do the same for this right hand bracket, so u plus 10 equals 0. Get our lines in and take away 10 both sides, so u equals minus 10. Now it might get confusing because it says find the value of u, but a length needs to be positive, so this minus 10 is not the correct answer. Our correct answer will be 8. And we can actually check this, because if I fill in the value of 8, so we can have 8 at the top here, and 8 plus 2, which is 10. 8 times 10 is 80. So we know that we've got the right answer. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So a plus b minus c will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9. And so that will be minus 18. So our column vector will become 18 minus 18. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8 w to the power of 10. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angled triangle and put the lengths as 1, we've got right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times top 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I go pick a point on my shape, and the bottom or the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. First thing I noticed with this question is we've got this nice triangle here. And we've got this kind of missing angle here. So we're going to work out what angle BCA is by doing 180, take away the 110 plus the 15, which is going to equal 55 degrees. And you need to write down the reason, and the reason you'd write down is angles in a triangle add up to 180. So this is 55 degrees. And the circle theorem says that when you have two angles coming from the same chord, so this angle and this angle are both coming from this chord here, they are going to be equal. So we know that x is going to equal 55, and that will be our answer. But you must write down the reason. And the reason is angles from same chord are equal. We can actually simplify the surd at the bottom. So root 12 is the same as root 4 times root 3. And the reason I've picked root 4 is because it's a square number. So root 4 is 2. Root 3. So we can rewrite that as 14 over 2 root 3. We can divide them on by 2. So that'll leave a 1 there. So it'd be 1 root 3 or just root 3 and 7 there. And when we rationalise the denominator, we times the top and bottom by the square root at the bottom, which would be root 3. And so that's going to be 7 times root 3, which would be 7 root 3. And then just 3 at the bottom. So our answer is 7 root 3 over 3. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagrams 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference. And the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So we need to start here by rationalising the denominator, because notice that the answer it wants is not in a fraction. So we're going to write out the question, which would be root 8 plus 50 over root 2. And we're going to times top and bottom by the surd at the bottom, which would be root 2. And so we're going to have root 2 brackets root 8 plus 50 over, and then root 2 times root 2 is just going to be 2. And we can multiply out these this brackets. So root 2 times root 8 is root 16, which is actually just 4. So it would be 4 plus, and then root 2 times 50 is 50 root 2, all of that over 2. And then we can divide top and bottom by 2 to get rid of the fraction. So that'll leave a 1 at the bottom, or just get rid of the fraction. 2 here. Now notice you've got to do all three terms. So we've got to divide this by 2 as well. So our answer will be 2 plus 25 root 2. And it won't be over 2 anymore because we've got rid of that. So it's just not going to be a fraction. And so A would be the 2 and the B would be the 25. We've got to subtract 1 outside the function. So all that means is we move the graph down 1. So instead of here, it's going to be down 1. Instead of here, it's going to be down 1. this bottom bit here will be somewhere down there, and just everything will be down 1. So it's not that easy to sketch, but we'll try our best to sketch it out. And we want to draw exactly the same graph, just down 1. To find the inverse, we're going to first of all, instead of writing f of x, I'm just going to replace it with a y. And the trick of finding the inverse is to swap over the x and the y. So we're going to swap them over. I'm just going to do it over to the right hand side over here, so we've got a bit of space. Now the challenge is to get it so that it's y equals rather than x equals. So we're going to start off by multiplying both sides by 4. And that will give us 4x on the left hand side, and it will get rid of the fraction on the right hand side, which was kind of the point. Next we're going to get rid of that minus 6, so we're going to add 6 both sides. And then finally we're going to get rid of that times 5 there by dividing both sides by 5. So we've got 4x plus 6 over 5 equals y. And we use y as a replacement for the inverse function of x. And so we're just going to say the inverse function of x, which is what that minus 1 means. It means inverse, equals 4x plus 6 over 5. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.